Okay, problem number 4, we have the sine of 2x plus the cosine of 2x. Because we have two different terms and they each have their own u, it turns out that u is going to be 2x for both parts. We actually want to think of this as the antiderivative of the sine of 2x dx plus the antiderivative of the cosine of 2x dx. This allows us to, in case 2x was here and this was like 3x, we could have two separate u's. But in this case, it turns out that u is the same thing for both. So technically we're doing it twice, but we only have to write it once. The derivative will be 2 dx. We don't have 2 dx, we just have dx, so we have to multiply the first and the second integrals by 2, which means we need the 1/2 out front of each in order to counterbalance. So what we're looking at here is 1/2 the antiderivative of sine u du plus 1/2 the antiderivative of cosine u du. Now we have our antiderivatives set up, so we can actually take the antiderivatives. 1/2 will stay. Sine's antiderivative is negative cosine, so we're going to have a negative 1/2 cosine u, and then 1/2 will stay for the second, and cosine's antiderivative is sine of u, and then we combine the two plus c's to have 1 at the end. So we're looking for a negative cosine, negative 1/2 cosine and a positive 1/2 sine, and that matches up with option B. With problem number 5, make sure it's on the screen there, there we go, we have e to an inner function other than x, so u is going to be the square root of x, which of course is the same thing as x to the 1/2. Alright, that allows us to find du, which will be 1/2 x to the negative 1/2 using our power rule, dx. And that doesn't look the same as this. However, if we rewrite du, alright, we have the 1/2, and then we have u to the x to the negative 1/2 is the same thing as 1 over the square root of x dx. So we can see here that we have the over the square root of x dx part. We have that part. We just don't have the 1/2. So we need to multiply by 1/2, and 1/2 on the inside leads to a 2 on the outside. So if we go down here, we have twice the antiderivative. E to the square root of x is going to become e to the u. And then everything else matches up right here, which is du. So we end up with e to the u du. And the antiderivative of e to the u du will obviously be e to the u plus c. And now we just need to replace x back in. So we have 2 times e to the square root of x plus c, which matches up nicely with option A. All right. And then number 6 here, we see more e's, but we have a fraction involved. Fractions, we're thinking it's probably natural log, and lo and behold, we do see some natural log involved here. If we try to make u equal to 1 plus e to the x, we would need the derivative of that. 1 derives to 0, e derives to itself, and then we have our dx, and lo and behold, there's our e to the x dx. Okay, so this leads us to the antiderivative of 1 over u du, which we know goes to the natural log of the absolute value of u plus c, and u is 1 plus e to the x, so we have the natural log of the absolute value of 1 plus e to the x plus c. E to the x is always positive, so when you add 1 to that, that's always positive. Hence, we don't need the absolute value markers, and we can choose option B.